Welcome to Speaking Concretely, the official podcast of the Cement Association of Canada. I'm Adam Auer, the President and CEO of the Cement Association of Canada and host of the Speaking Concretely podcast. On today's episode, we have the privilege of speaking with architect Sasa Radulovic, founding partner of 5468796 Architecture in Winnipeg and fellow at the Royal Architecture Institute of Canada. Sasa and his firm have received national and international recognition and are credited with many bold new additions to Winnipeg's cityscape, contributing to a rebirth of the city's architecture. Some notable projects for the firm include the Parkade of the Future and the 17th Avenue Clinic in Calgary, as well as the Old Market Square Stage, 90 Alexander, and the 62M condo in Winnipeg. These projects really are quite stunning, and if you're interested in learning more about them and to see pictures, I encourage you to visit their website at 5468796.ca. I think it's fair to say that both the concrete industry and architecture are evolving in the face of shared and unique challenges, new technologies, new aesthetic preferences and market pressures, as well as increasing pressure to both decarbonize and adapt to a changing climate through more resilient design. So it's an interesting and important time to be having a conversation on the use of concrete. What is the role of architects in shaping the future of design and construction in ways that will affect the use of concrete in a changing built environment? Welcome, Sasa, and thank you for joining us today on Speaking Concretely.
Thank you, Adam, for that generous introduction. I'm looking forward for the chat.
Fantastic. Well, to get started, why don't you tell us a little bit about yourself? When did you know you wanted to be an architect?
My dad was an architect, so I took interest, I think, as early as I was 2 or 3 years of age, and I've never actually looked anywhere else since. I wanted to be an architect. It took me a while, as you described, through a series of different schools to get to the position of becoming a registered architect. But it's been the last almost 50 years that I wanted to be an architect.
Are there architects or a particular architect that inspired or influenced you the most?
You know what? That's a tough question, loaded, perhaps, and it probably changes often as one matures in their understanding of what architecture is. Again, being exposed to books on architecture, being exposed to understanding on what architecture meant through my dad's eyes, I sort of have looked at a series of architects from early age. So it really is hard to pinpoint one. There are a lot of architects around the world practicing remarkable architecture these days and through the history as well. And so I would be remiss to suggest any one of them actually was something that attracted me or influenced me the most.
Well, this might be a similarly loaded question, I guess, but would you say that you have a particular design style as an architect?
Today and throughout the history, it really almost always required a team of architects to deliver a project, and we generally think of figures that as a sort of singular authors of work, and while many still subscribe behind that understanding, I'm firmly of a belief that that architecture is a contact sport and it is a team sport. So ultimately, the architecture as a style, the way we think about it, is somewhere between the method and the attitude towards any particular problem or a project.
Well, that's actually kind of a great segue to my next question, which is introducing, the topic at hand, concrete. Architect, you say, is a sort of a team sport, evolving with the sort of technologies of today, with some of the learnings of the past. Where does concrete fit into that conversation? What would you say is the perception of concrete and the concrete industry in the eyes of architects today?
Concrete is one of those materials that, one of the last remaining materials on in the contemporary architecture, when you are, in particular, when you're looking in sort of Western world, the levels of installation and building science around envelopes are such that the multi-layered envelopes are required, and therefore structure is often concealed behind it, and particularly approach to concrete has sort of gone to the point where we see less and less of it in its exposed, most beautiful way. So why do I say between love and hate? There's a beautiful freedom and expression that concrete allows us to employ in design and design of the buildings and actually ultimately their aesthetic and function. Often we are at the mercy of the particular trade that is working in concrete, and therefore we have to adjust not only our expectations but the ways we approach the methods of casting and the types of concrete that we use. But on the flip side, we all struggle with the embodied energy that concrete, especially in a contemporary architecture, that concrete brings with itself, and always try to balance its robustness, its longevity, its ability to actually last and understand its carbon footprint over 100 years rather than one on the day of installation. And I think we're going to talk a bit more about the parking of the future. The idea of using a concrete frame on that particular project for us was a necessity because we were tasked with creating a structure that can be converted anywhere from parking today to commercial to residential to light industrial in the future. And the concrete was the only material that checked all the boxes at a time. We were both very happy because the structure and the concrete in its all beauty could be expressed through the building itself, but leery of the use of such a high amount of concrete on a building with today's understanding of its carbon footprint. However, when we factor in the 100 years or 150 or 200 years, hopefully, that building will stand up given its ability to change its use, then we can start to think about concrete differently.
That's the Parquet of the Future project that you're talking about that we mentioned in the intro, I think. And actually, let's get into some of the specifics, because you and your firm have designed not just the Parquet of the Future, but a number of other notable projects where concrete was central to both the function and the design of the project. And maybe you can provide our listeners with some insight into how you typically approach designing with concrete in terms of that sort of balance between aesthetics and functionality.
For sure. We primarily practice in Canadian context. The projects that you've mentioned are all in Canadian prairies that are characterized by the severe climate that goes with temperatures that fluctuate between minus 40 Celsius and plus 40 Celsius. And I think that's minus 40 Fahrenheit to 100, 105, 110 Fahrenheit for the American listeners. And we often deal with those temperature fluctuations. We deal with sun washing out all the materials and finishes, if you wish, the strong prairie sun in the summer, or really severe icing and snow in winter, and then shoulder seasons that put us through a fair bit of moisture and so on. So envelopes in Winnipeg in particular, but also across the prairies, are really, really complicated when it comes to balance between robustness and the elements. And again, due to the variation and gaps and extremes. And so often the only way to confront those elements, in particular around the grade at that pedestrian level, or where most people experience our buildings, is through use of concrete. And so in Winnipeg, in particular, I think we're looking at about 30% of the costs being sunk between the foundation and the first level of the building, which typically requires to be something that will again withstand all the climatic conditions. And so we often look to concrete as a material that can bridge, solve, and outlast any other assembly, if you wish, or a means of construction right there at grade. And so that's where the aesthetics and the functionality kind of come together to try to do both. On a project that we did on Alexandra Avenue called 100 Alexandra, the concrete columns, both sloped and vertical, obviously addressing lateral and gravity loads in two separate ways, are growing out of the ground, and they are the way the building meets the ground. For the most perimeter of the project, and then the attempt, of course, is then to create concrete that is that is finished in a way that does not need to be covered. And one of the things that we see in a trends of contemporary architecture is a tendency to cover the structure. So the buildings are far less. It's far less obvious how buildings are built and constructed. And it's one of the things that we always go back in our work is trying to express that tectonic quality of the materials and systems used. So concrete comes in as a perfect example of or a perfect medium to do that. Again, balancing between the function, the technical requirements, and the aesthetics.
I'm going to get into the carbon challenge in a couple of questions from now. And our previous episode actually focused almost entirely on the sort of embodied carbon and sort of industrial policy around reducing carbon in our materials. And I'm looking forward to chatting with you a bit about that. But one of the things that you mentioned in particular around the Parkade project was this notion of adaptability. And in our previous sort of conversations and prepping for the podcast, you mentioned how adaptability was a really central part of the design of the Parkade of the future. And it's obviously such a crucial aspect to sustainability and the longevity of our structures. I wonder if you could tell us a little bit more about how that sort of adaptable quality to the design of the Parkade was central to its design.
Yeah, it's sort of curious, and when we go into the design process, we recognize that it's iterative, and we try not to preclude any solutions. And so by keeping our minds open as long as possible through the design process. So as we were trying to understand this idea of adaptability, obviously the longevity is a very critical component to adaptability, because if the structure was not constructed in a way that could last 100 or 200 years, then the idea of adaptability would fall flat, as the structure wouldn't last. We've modeled our thinking after warehouse buildings that were built in the turn of the last century, so in late 1800s, early 1900s, that are present throughout North America, and pretty much everybody should be familiar with those, which are consisting of exterior load-bearing walls and a heavy timber column, post and beam, I guess, structure within. And those buildings are now in their 100 or 150th year of existence, have withstood changes from warehousing to industrial, to light industrial, to low grade office space, to high grade office space, to condominiums and residential, and so on. And they're not showing any signs of slowing down. And so the approach to the Parkade of the future was trying to recreate the modern version of the post and beam structure that is kind of stays out of the way of any one of the potential adaptations or versions of the building in the future. So concrete was the only material that sort of checked all the boxes in terms of longevity, ability to provide rating inherently, ability to span, ability to, without significant additional cost, provide different bearing capacity for different uses, and so on. And so then we started looking at the environmental impact of concrete frame for the building over 100 or 200 years, and understood that initial CO2 impact was significantly reduced by considering that length of a life of a building. And so I think there's smarter people out there that can calculate the impact of that building much better. However, the thinking behind it, I think, paves the path for how we should be working and thinking about our buildings, because I think the time when we thought the buildings that we're building are going to remain as such for long periods of time or forever is long past. The world's moving faster we think, and than we can think at the time of the design, and we have to not preclude futures from happening.
I think that's a really commendable approach to design. I mean, I know I want to sort of switch to the sort of carbon and broader sustainability aspects of the conversation now. I know from our previous chats that you're aware of our Concrete Zero action plan, which is quite heartening to know that you had come across it already before we reached out to you. But one of the elements of the modeling that we do around the decarbonization of our sector does speak to this notion of material efficiency, which is both about designing efficiently, so not overbuilding, optimizing your mixes for carbon, and of course not designing for disposability like so many of our buildings are today. We, even in our life cycle assessment analyses, we're kind of constrained to 60-year assumed lifespans, because on average that's how long a building lasts, not because it can't last another 100 or 200 years, but because its function is no longer fit for the market purpose of the day, and so it gets torn down and something new put in its place. That's just one sort of aspect of the whole, I think, sustainability challenge of the cement and concrete industry. But from an architect's perspective, how do you integrate, beyond just the adaptability, thinking of the future uses of the building, how do you integrate sustainability practices into your design when specifying concrete or other low carbon materials?
Architecture is a slow sport. It takes quite a while. The buildings of any reasonable size will take 4, 5, 6, 7, 8 years to be completed, and throughout that time, there's a variety of factors that will influence ultimately the system selected for a building, but the budget, among many things. And we've lived through 4 or 5 or 6 years of relatively volatile, or perhaps it wasn't moving as fast as we wanted it to, but it certainly has affected the costs of anything from building materials to labor to borrowing money and so on. And so often, even if we design a building and it meets the budget at year one, by the time it gets into construction, year 2 or 3 or 4, the market conditions have changed in a way that the budgets either have to be increased, which is rare, or have to be the selections we make as architects or as designers or as engineers would have to be changed in order to meet the budgets of the building, which is where a process that's industry-wide understood as value engineering, although we like to think of it as value architecting, from our perspective, is a process where you look at every system of the building and see if there are potential savings. And so those savings are often found in lowering the spec requirements, the specification requirements, directly relating to your question, specifications about concrete. The more sustainable the concrete is, the more expensive it is at the moment. And I think that's the simplest way of saying it. So getting your generic run-of-the-mill concrete mix is still the cheapest concrete you can get, and ultimately the product once finished is the same. And so commonly architects on the instruction, if you wish, or recommendation from the contractors or their representatives will sort of remove the requirements for low carbon concrete as a simple way of finding additional savings in a project. And so we've faced that issue. We faced that issue multiple times. So how does one combat that? Well, if we know that it's coming, then we have to think about concrete as something that does not only meet a single or a singular use or purpose in any project. So we're trying to make it work hard, trying to make concrete work hard to meet the technical, to meet the performance, to meet the aesthetic, to meet the ultimately programmatic requirements on any given project, and therefore not like a kind of spread its impact across different components of any given project. And by doing that, we are further justifying its use to ourselves. We're further justifying its use in sort of the spectrum of its environmental impact, because as you mentioned, Adam, the robustness and longevity and the ability to stand up much longer than 60 years are the qualities that we think of when specifying concrete.
So carbon is definitely on the mind, but you've highlighted some of the practical barriers, and we often hear that cost is a barrier to sustainability in general, not just when we're talking about lower carbon concretes, but other materials, other products. At the same time, I've certainly heard in my conversations with other construction industry professionals that, even if the price of materials were to increase significantly, say 50 or 100%, the impact on the overall cost of the project when you're factoring in labor and all the other costs that, the cost of the land, insurance, et cetera, is actually relatively small. But you're saying that even those small project level changes in cost can be effectively a barrier to low carbon decision making.
That's certainly the case, and you're absolutely right. The way the projects are looked at varies from project to project, and and whether one looks at the overall project cost or looks just at the construction cost at any given time affects our selection or choices during the design and construction. And I think the world's moving towards an understanding of the actual cost of a building over its lifetime as something we should be looking at, because I'll be wrong in quoting the numbers, but the actual construction of the building is in well under 10% in terms of the building's impact on the environment and the embodied energy, as well as impact on on carbon dioxide. Our thinking is that once we get that far in our understanding of the built environment, then our choices that are really representing, not 1%, not 0.1%, but maybe 0.01% or less of a project cost would be less. They are the real costs that are facing at that particular given time, but they're so minuscule when it comes to overall impact that the built environment has. So yeah, you as an association should definitely be talking to the policymakers and the in such, and to help us understand the costs of our building over time, and therefore make those choices, or help us make those choices the right way when the impact on cost is so minimal.
That's great.
But the impact on environment is so significant.
Well, I can assure you that we are having those conversations, and one of the reasons why we've put out this podcast is to kind of fertilize the ground for these types of conversations, and hopefully open the door for collaborations with architects and others in the construction value chain to help affect those policy changes that we need to make, the sustainable choice, the profitable choice for the design of our built environment. Let's assume, and I am an optimist when it comes to the decarbonization of our sector and the built environment as a whole. We have in our action plan targets to reduce the emissions from cement and concrete by 40% by 2030, almost 60% by 2040, on the road to net zero by 2050. And, let's assume that we are successful in achieving these targets, which I think we will be. How does that change your thinking about the material, or how does it change how you think you would integrate concrete into future designs?
That's a very interesting question. The tendency today in a large percentage of architectural production is to use concrete for its structural capacity and then clad it and hide it, either because the installation is insufficient, or we don't think of concrete as a beautiful material. It is one of the most malleable and capable materials of elevating an architectural project. And but the industry has moved most recently, more and more so, especially again in the northern climates, to the places where we conceal, hide, and the concrete, and use it singularly for its robustness in the or structural capacity. And so I'm curious, after another 25 years of that kind of thinking, if architects are using concrete as purely for its structural capacity. I'm curious how long it's going to take to undo that and unthink that, because the concrete, zero carbon concrete, becomes a material that we should all be looking at using. At least that's my understanding currently, because because of its impact, but also because of I guess, a reduced impact on the environment over time once the building is built. So it becomes, in some respects, similar to how we think of wood as a renewable resource. The concrete, the zero carbon concrete, becomes a material that keeps on giving after it's been installed in the building. So that's how I would think about it. That's how I hope we can all wrap our heads around it, as architects and as people in the building industry. But until then, we're going to make a significant impact on the environment. And that's one of the things that we're all struggling with and trying to figure out how to, including you, trying to figure out how to get there faster, for one, and how to use concrete in a way that will pay back in the future.
Well, as we think about the future, then maybe I'll ask as a final question for some crystal balling about what you see, sort of what sort of technologies, trends, or maybe even regulatory developments you see on the horizon that you think are going to kind of influence design over the next decade. Are you seeing anything in our sector? We talked a little bit about the decarbonization plans, but are there other sort of technologies or practices that you've got sort of your eye on that you think are going to have a significant influence on the use of concrete in designs of the future?
Well, it's interesting. Again, we spoke about this earlier. The building codes seems to be increasing the amount of concrete we use, just because of the levels of or coefficients of safety and the requirements on rebar coverage and so on and so on. And so while we're trying to reduce our impact on the built environment, we're all up against the building code. So we're working with engineers often to try to reduce the thickness of our elements, thickness of our concrete walls or beams and sides, in order to reduce not only their apparent scale, but actually the amount of embodied energy in our buildings. And so we are hopeful that through more and more modeling and integrated design, we are going to get there. However, I think the work needs to be done and understood on a higher level in terms of regulations and the requirements that we see in the building codes. So I think more holistic understanding of the structures as enabled through advanced computer modeling is capable of reducing the amount of materials that we use, and I think that should be every architect's goal when it comes to any material, but in particular concrete, where scaling the elements down from what they need to be or what they want to be based on either certain assumptions or the building codes should be part of what we do and how we deal with how we deal with concrete in our work. Again, we spoke a little bit about the 3D printed structures and so on. And while, again, they might work in certain climates where we function, our walls are generally 10 layers or more. Only one of them is structural. And so we see that those kinds of advancements are still not crossing the line into the high efficient envelopes and high levels of insulation. So we are not seeing that taking over the construction again in our climates. So whether AI was able to provide additional answers when it comes to complete integration of design and optimization of structures remains to be seen, but I'm hopeful that we'll be able to again reduce the amount of materials that we use in our buildings to achieve both robustness or similar levels of robustness, but with far less resources.
I really like that answer because, in our industry, we've been working quite deeply in the codes and standards process to move us away from the sort of prescriptive approaches that you describe, where we're seeing, like a almost like not a dematerialization, but a rematerialization to reflect even more conservative assumptions around safety and whatnot. We would like to see a much more performance-based approach to design that would, we think, yield opportunities to, think of materials, not just concrete, all materials, like energy. We've invested a huge amount in reducing the amount of energy that we need for lighting and appliances, et cetera. And I think the same kind of thinking needs to go into the codes and standards process to help dematerialize to the extent possible our built environment through more optimal use of materials like concrete. So that answer really does resonate with the work that we're doing at the association and with the discussion that we've tried to start with our net zero action plan. So thanks very much for that.
When I started work in Canada 25 years ago, our typical concrete foundation wall was 8 inches thick, and it was thinner than that prior to that. Nowadays, we rarely pour a foundation wall that's less than 10 inches thick, so that there's the increase of 25% in terms of concrete volume required for a foundation wall for a variety of reasons. And instead of going the other way, you would think with better engineering, we are actually spending more resources and embedding more energy into our projects than we did 25 years ago.
Well, Sasha, thank you so much for being our guest on this week's episode of Speaking Concretely. I thought it was a really fascinating conversation, and hopefully a conversation that will really sort of showcase both the versatility of our podcasts and opening up topics of conversation that are important to our sector and to the construction industry as a whole, but often overlooked. Some of the challenges that are sort of implicit in our construction process that we were just talking about in terms of codes and standards and over design and the challenges of overcoming those. These are really important conversations, hard conversations, but exactly the kinds of conversations that we're looking to facilitate so that we can find solutions.
Thank you, Adam, for inviting me to take part in this podcast, and I'm looking forward to the future episodes.
I hope this episode offered valuable insight into the relationship between architecture and the concrete industry, and that it helps inspire other architects to consider collaboration with the cement and concrete industry in their future projects, especially as they plan for sustainability and decarbonization of the built environment. Thank you to our audience for listening, and don't forget to subscribe and follow our podcast on your favorite podcast platform. If you've missed the first 2 episodes, take a listen to them now, and we hope to see you next time. Take care.